Bismillah, walhamdulillah, wassalatu wassalamu ala rasulillah, wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri, wa yassir li amri, wa hlul uqdatan min lisani, yafqahu qawli. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, I welcome you all to our fourth tutorial this year, inshaAllah. This is on Linux and Git, and it will be hosted by our tech lead, Bayan.
Assalamu alaikum, everyone.
Okay, now before we start, we'll have a short recitation from Dawood.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم هو الذي جعل الشمس ضياء والقمر نورا وقدره منازل لتعلموا عدد السنين والحساب ما خلق الله ذلك إلا بالحق يفصل الآيات لقوم يعلمون.
He is the one who made the sun a radiant source and the moon a reflected light with precisely ordained phases, so that you may know the number of years and calculation of time. Allah did not create all of this except for a purpose. He makes the signs clear for people of knowledge.
إن في اختلاف الليل والنهار وما خلق الله في السماوات والأرض وما خلق الله في السماوات والأرض لآيات لقوم يتقون.
Surely, in the alternation of the day and the night, and in all that Allah has created in the heavens and the earth, there are truly signs for those mindful of Him.
إن الذين لا يرجون لقاءنا ورضوا بالحياة الدنيا واطمأنوا بها والذين هم عن آياتنا غافلون.
Indeed, those who do not expect to meet us, being pleased and content with this worldly life, and who are heedless of our signs,
أولئك مأواهم النار بما كانوا يكسبون.
they will have the fire as a home because of what they have committed.
إن الذين آمنوا وعملوا الصالحات يهديهم ربهم بإيمانهم تجري من تحتهم الأنهار في جنات النعيم.
Surely, those who believe and do good, their Lord will guide them to paradise through their faith. Rivers will flow under their feet in the garden of bliss.
دعواهم فيها سبحانك اللهم وتحيتهم فيها سلام وآخر دعواهم أن الحمد لله رب العالمين.
In which their prayer will be, Glory to you, O Allah, and their greeting will be peace, and their closing prayer will be, All praise is for Allah, Lord of all worlds.
We'll pass over to Rihanna, inshallah, and he'll continue with the tutorial.
Assalamu alaikum. Inshallah, you're all doing well. And let's get started with the tutorial. So, what is Linux? You may have heard of this, you may have not, but pretty much Linux is an open source operating system. Probably one of the only open source operating systems. You have things like Linux, Windows, Mac, iOS, Android. These are all operating systems, but Linux is the only one that's open source. What does that actually mean, though? It can constantly be developed. So in other words, they have a community of people constantly building it. And because of that, it's basically tailored towards any application or any sort of usage that you need for it. So this is one of the reasons why it's used everywhere, specifically as well in servers. So for most of the applications that you're actually running, they have Linux servers running in the back end. And if you're looking to get into tech, Linux is one of the most key skills that you need to know. But why do people actually use Linux? Yes.
There's a question.
Oh, yes. What is an operating system? So, an operating system is essentially a way to interface you with the computer. So by providing a GUI for you to interact with. What does this mean? So, as you're seeing, you may be using your MacBooks right now. You have a cursor, you have applications, you have files, you have a trash bin to put away files in. All of this is done because of the operating system. As well as that, there's other things, the Wi-Fi you're using, the Bluetooth you're connecting with. All of this is only possible because you have an operating system in the back end. So, getting on with this, why are we actually going with Linux? So, we actually have multiple people that are developing these systems and making it as optimal as possible. Linux specifically is known for its lightweightness. As well as that, there's no redundant apps on install. So, for instance, if you're using a Windows device, there's a very good chance that you have probably about 100 to 200 apps when you first load it up. And most of these apps you'll probably never use. Linux doesn't do this. They only store exactly what you need. And generally, it's more secure than Windows. As well as that, it's customizable, which we'll go over later. So, firstly, if you actually see this graph here, the light blue bars that you see are the results of a benchmarking. So the light blue ones represent Linux, dark blue represents Windows, and the white one represents Mac. What does this actually show, though? It shows the general spec on a benchmarking tool. The higher the score, the better. I see that there's a question answered. Oh, can you give some examples? Could you clarify examples of what?
I think they meant about lightweight.
Oh, yeah. So in this case, you can see how lightweight it is, for instance. So because it's running on very minimal software, meaning that there's very few apps that are running in the background and other things, it allows it to get a higher benchmark score on the same hardware. So as you can see, Linux basically tops the charts on this. Now, as I mentioned before, Linux is customizable. Enough so that there's different versions of Linux. So think of Linux as the sort of parent and it having essentially many different versions of itself that are specific for different things. So for instance, Android is one version of Linux that has been tailored for mobile devices. Similarly, there's other versions as well. The main one that you may hear when you hear Linux is Ubuntu, which is known to be beginner-friendly. There's other ones that are good for enterprise. So for instance, Red Hat. There's another question as well. Let me just get to that. Apparently not. So let's carry on. So as you can see here, here's the main top sort of Linux distributions that you may hear about. So Ubuntu, Linux Mint, Arch, Fedora, so on and so forth. All of these different ones have been tailored for their own purposes, and it's very likely that you'll come across these in your career. Now, when you're working with Linux, it's very likely you'll work with a command line, similarly to how you might use PowerShell in Windows. Linux has something similar, which is called Bash. It's a scripting language. But what does that actually mean? It allows you to run commands that actually allow you to interface with the system rather than relying on a GUI or human input. So, what actually is Bash? It's something that can run on a Unix-based operating system. Now, Unix is a family of operating systems, of which you may have a lot of different operating systems under it. So Linux is one of those, Mac and Android are also them. Because of that reasoning, since Bash can run on Unix, and these three operating systems are also Unix, it's possible to be able to run Bash on these as well. So in other words, Bash can be run on Linux, Mac, and Android. So if you're using a Windows computer, you might think, hey, why can't I use Bash? Well, actually you can, and there's a few different ways you can do this. Firstly, you can potentially download an application called Git Bash. What this does is it allows you to use Bash, but on a Windows computer. Basically translates the commands to be able to run on it. An alternative, though, which I recommend is WSL. Reason being is that it's a bit more powerful and you can get more done with it because you can download apps on the fly. You can upgrade it on the fly, so you can download different packages to run on it. So what this means is during the tutorial, I'll be showing you different commands you can run in Bash. There's certain commands you won't be able to run unless you install relevant packages. You might be able to learn this later on, but you'll only be able to do this on WSLs, hence why I recommend it. Another alternative I'd recommend is dual booting. One of our brothers, Yasin, has actually done this. So what this means is whenever you shut down and turn on your computer, you're able to choose whether you want to run Windows or whether you want to run Linux. And both of these are running on your storage. So let's say you have a computer with 512 gigabytes of space. They might allocate a bit towards Windows, a bit towards Linux, and that way you get the best of both worlds. You can basically work on both sides for your own purposes. Maybe use Windows for things like most Windows applications like Microsoft Word and PowerPoint, and you might be able to use the Linux side for your programming. Now, if you're using Mac, as I mentioned before, Mac can run Bash, meaning that you don't need to worry about it. It goes hand in hand, as I'll show you in the tutorial later on. Yes. Yes. Yeah. So is dual booting basically just a virtual machine? No. it's not a virtual machine. It's basically seen as its own sort of operating system within your computer. So how it works under the hood is pretty much that you sort of have a file system, which is called Grub, not a file system called Grub, a sort of like boot manager called Grub, which allows you to either start your computer as it would have before with Windows, or you might choose to have it instead run Bash, not Bash, Linux. What other questions? What would you use Bash for? So when you are working with servers in the future, of which most use Linux, you will need to use Bash to be able to actually communicate with that server to be able to do whatever you need to do. So for example, let's say for some reason in the future, a database goes down and you're working on some AWS machine running Linux. You will need to know Bash in order to actually spin that database back up. Similarly as well, later on, if you attend our DevOps tutorial on Monday, inshaAllah, you'll find out that you'll need to be able to test, deploy, and basically monitor your code. Most of this stuff is done with Bash or with general command line interfaces, but almost always it is using Bash because most servers use Linux. I think there is another question. Let me just check. Yeah, what is a virtual machine? Technically, it's not being talked about as much in this tutorial, but Git Bash or WSL is a virtual machine. What this means is it's pretty much a machine running in a machine. So think of it this way. You're running Windows on your computer, right? Imagine if you had a way to run, let's say, Mac inside that Windows interface. That would basically be a virtual machine. So it's something that is seen as its own secure container where you can run your own code under any operating system that you choose. So this way, you're not limited just to the bounds of Windows. Now, yeah, with a virtual machine, you can basically run whatever you need to. So let's say, for instance, you want to run, let's say, Linux within a machine. You can do that. So let's get on with some other questions. What's a server? So a server, pretty much think of it like this. You're running an application, and you have a database in the background that's storing customer data. You need something running 24/7 in order to be able to constantly interact with it. So you may want to find out, let's say, is a customer making an order, or what is a customer's order? Most of this stuff is stored on a database, and this database is being operated by the server. So the server is sort of a way of being able to keep your application running even when your computer is turned off or someone else's computer is turned off. Let me just clear off these questions that have been answered. That one's done. That one's done. That one as well. There. So, getting on with file systems. When you're running Bash, Bash, you basically work with a file system. So think of this as a start point for when you're running your Bash programs. So here we can see basically what a file system is. You start off here with Tom. There. You start off here with Tom. Basically how this works is pretty much as it would with folders when you're working with the program. You'd have a folder. That folder may contain more folders, which may contain files, which may contain more folders, so on and so forth. Now, the way that this actually works in Git is basically you have to constantly navigate between these folders and keep track of where you are as you're basically running these programs. So you may start off in Tom, you may move into a folder called data, and you may want to access 1.txt, as you'll see in the tutorial. The reason I mention this is because throughout the tutorial, I'll be constantly moving from folder to folder. There'll be a few commands that I'd like you to keep in mind the file systems when it comes to it. Now, this is what a Linux file system looks like. So as you can see, a lot of these folders start with /. These are ones that are almost common in every single Linux system. So you have /, which is known as the root. This is where your entire file, like your entire Linux operating system is stored. And then here, you have a bunch of specialty folders. You have user, which relates to you specifically as a user. So for example, imagine you're on a Windows machine or a Windows PC, and you have your family working on it as well. You may have an account for yourself, maybe your siblings, maybe your parents. Each of these would be stored separately in each user folder. You may have a home one to, for instance, store any other data that may be central to all of you. The reason I'm mentioning this is because all of these are known as their own sort of areas that you can CD into. You'll learn what this actually means during the tutorial. So let's get started with the tutorial. And inshallah, I'll come back to this to explain this in a bit more detail. But first, let's check any questions. In 30 seconds, can you explain what makes Linux disadvantage? Oh yeah, so one of the biggest disadvantages to Linux is that not too many people actually know about it outside of the software world. Almost anyone that doesn't really know too much about computer science probably doesn't know what Linux is, and they tend to either stick with Windows or Mac. Because of that, you tend not to see too much publicity towards it. Another disadvantage is because a lot of people don't tend to use it, most products aren't actually on Linux. So for example, let's say Steam, for instance, they aren't really optimized for Linux, but they would be more so for Windows or Mac. Similarly, other applications too, like for instance, Word, PowerPoint, Excel, all of these aren't native to Linux, and you need to use your own versions. This is probably one of the biggest disadvantages of Linux that you actually need to take into account. Hence why most people dual boot rather than running Linux separately, because there's a lot of things that you can't do with it. But the programming things that you can do are much more powerful on Linux compared to anything else. So now, inshallah, let's get started with the demo. Firstly, does anyone have any questions that they'd like to say aloud? Nope. By the way, at any point, feel free to raise your hands and ask any questions, not just on the Mentimeter in case I do miss it. But let's get started with the demo. So, I mentioned the file system before. The way that you can actually find out where you are relevant to your program is to do the command pwd. This means print working directory. So now, going back to the tutorial, as you can see, there's a /users/admin. /user refers to this part here, and /admin refers to the actual person that this is registered with, which is me. If I had a different account, it would be different. So first, I'll teach you how to move in and out of folders. First, you want to see what's actually available. So for instance, if I were to open File Explorer, there, you may want to see where you are, see what documents you've got, what downloads, so on and so forth. The way that you'd actually do this in Linux is first using ls to see what you're dealing with. So as you can see, there's the folders that are very common to pretty much every operating system. You have your desktop, documents, downloads, libraries, so on and so forth. But for the purpose of this tutorial, we're going to be working in the downloads directory. So how do we actually move there? Because there's nothing to click. So the way that you do that is with the cd command. What this means is to change directory. And now you need to type in the directory name. In this case, it's downloads. Now we're in the downloads directory. And if we do pwd, you can see that we're now there. By the way, I do recommend if you have any sort of terminal installed, or if you're on Mac, for instance, or have Git bash or anything, feel free to follow along. So, as you can see, we've moved from user/admin towards downloads. Now, suppose that we didn't want to go into this folder. With something like Finder, you could just press the back button and go up. The only way that you'd actually be able to do this in Linux is to cd and do double dot. This basically means to move out of the folder. So now we go from user/admin/download to pwd. There. We go from user/admin to downloads to user/admin. So we've effectively moved out of that folder. And you can chain these together. So for example, if I was to go back into the download folder, and I wanted to go 2 steps out. So in other words, if I wanted to go from downloads to users, I'd have to get out of 2 folders. And rather than typing that twice, what you can do is go out of the folder and then go out of the folder again. And that allows you to basically go out. You can do this the other way around. So if I want to go back to the downloads folder, I can go to admin and then to downloads. Now that we know how to navigate these file systems, now it's time to get on with some more stuff. So the next command that I'd like to check, actually I've got a question just now. Why would you do it with the command instead of File Explorer? So generally speaking, when you're working with your own computer, you might not need to use it as much. But when you're working within a virtual machine or in a server that is running operating system different to your own, or even running Linux, you will need to use the command to be able to go to different folders and do different operations there. As well as that, let's say you're running a script that's somewhere. You might not be able to do this normally with VS Code by like double-clicking like you would with a normal application. You'd have to move to that folder and run the program, and the only way to do that is by using the command line interface. you can't really do it as well with the File Explorer, or sometimes you might need to pass arguments, which we'll learn about later. A directory is pretty much a folder. So if we go back to Finder and we go to, let's say, downloads, nope. There. So as you can see, in these, in my File Explorer, you can see there's files here, and you can see there's folders. All a directory is pretty much a folder. Let me just check for other ones as well. Yep, so why would you be working on a server and not being able to see it? The main reason you can't is simply because most servers don't really have that capability. Instead, they're only something that you can go into and work with. You can't really have a GUI separate for it. Reason being is that it tends to have many users working on it at the same time. So in an organization, you might have 50 people seeing the exact same thing, and how would you be able to show a GUI like that? A GUI is pretty much this desktop here where you can sort of see and interact with things. Instead, the only way you can interact with it is through this command line, through bash, or similar. I see that there's more questions, so we'll go through it. Is it okay if you explain what you did one time and why? I'm not sure what you mean by this question. Yeah. Feel free to explain the question if you'd like to clarify it a bit more. No one? Okay, I guess the assumption is probably what I did in terms of needing to use CLI. Okay, so in one of my projects, we needed to host a AWS instance. So basically, Amazon has their servers, and they market themselves as AWS, Amazon Web Services. They provide virtual machines that we can work with. That way, we don't need to keep our computer running 24/7 in order to keep our applications up. Applications are pretty much like websites, the apps that you click on, so on and so forth. Now, in order to actually get things up and running, we have to spin up databases on that server. So in other words, we need to spin up the things that will contain user data. We can't simply open up a File Explorer or Finder and just actually do things there. We have to actually run bash scripts and pretty much spin up those instances and populate it with data. This is one time where there was absolutely no way for me to do it with a GUI. I had to have used bash to do it. Otherwise, I wouldn't have been able to do it at all. It wasn't just a matter of efficiency. It was a matter of functionality. Oops. What's operating system done? So as mentioned before, bash is used for very necessary things such as running scripts, being able to run up databases, as well as Docker containers, which you'll find out if you attend the DevOps tutorial. So I strongly recommend attending it on Monday. That one's done, and that one's done as well. Yeah. So let's get back on with the tutorial. So from here, we've learned how to navigate different file systems with ls, cd, and pwd. Once again, iterating over it, cd is to change directory, ls is to list the available directories and files relative to where you are, and pwd lists where you are relative to the rest of the file system. Now, in Finder, you might be able to create a folder by just clicking a button. Now that we're working with bash, we can't just click a button to create a folder. So how do we do that? We do that with the mkdir command, which is mkdir, which stands for make directory. We have to pass an argument, that being the directory's name. So for this, we would pass in a name, which we'll call tutorial in this case. And now, if we do ls again, rather than seeing nothing, we now see the file that we created, which was tutorial. Let's cd into this. Now, if we pwd, we should expect to see user, admin, download, and tutorial. Now, I think now's probably a good time to have a 5-minute break just to answer any questions, because we have covered quite a bit of content. If anyone does want to ask any public questions, feel free to raise your hand. Otherwise, feel free to say it on the Mentimeter. And inshallah, see you guys in 5 minutes. Yes? What do you mean by that? If you wanted to see what? Yep. The main way that you can do that is by changing directory towards that file and then running ls there. But I believe you can also do that relative to other content. So what I mean by that is, we're in tutorial right now. If we want to list what's in admin, we could basically provide the path to get to admin. And I believe this should work. And it does. So pretty much what this does is it changes directory to go to ... which means to leave the folder. We do that again. We're in admin. And then from there, we run the ls command, which lists all of the files. Does that answer your question? Yeah. Now, I think now's probably also a good time as well, just to do a bit of a short quiz, if you guys are interested. So, when it comes to Linux, what's the command to be able to change directories? Feel free to raise your hand. Yes? And that changes directories, yes. Now, how about for finding out the relevant directory that you're in? Yes? And finally, how do you list what files and directories are available? Yes? Yeah. And inshallah, I'll see you guys at 6:50, inshallah. Assalamu alaikum. Inshallah, we'll continue with the next part of this tutorial. So, I got this question recently on Mentimeter. What does sudo rm/rf do? Firstly, technically speaking, that would just remove a folder called rf. Reason being is that I think the intention of the command was meant to be different. And that also reminds me that I've actually missed a topic that I should probably talk with you guys about. The use of flags. So almost every command in bash can be passed a thing called a flag. Think of this as an option. So with ls, where you're listing the contents of a directory, you might want to pass a flag and change what it actually does. Rather than just showing files and directories, what if you want to see hidden files? What if you want to see more options of the file, more details on the files? So like how much storage it takes up, what permissions a user has to interact with it, things such as that. To do that, you'd need to pass a flag. So how that works is you'd pass in the command, which is ls, and you'd pass a hyphen character, and then the option you want. So two that I'll go over is ls-a, which lists everything. So in this case, there's nothing in the folder, but there are two items in it. The dot, which basically does nothing, it's basically referring to itself, and the dot dot, which refers to the parent. If we leave this folder, and leave the other folder as well, here, we're in the admin directory, but if we run it here, ls-a, you'll find out there's hidden files. And most of these are prepended, which means they begin with a full stop. So these are all the folders that are hidden if you go to somewhere like Finder. So for example, as you can see in my, if we leave desktop, and we go to just admin there, as you can see, there's desktop, documents, downloads, movies. None of the files here actually start with a dot because they're hidden. The only way you'd be able to find it out on Finder is to do Control-Shift and full stop to show these hidden files. The command ls-a allows you to basically do the same thing and see these hidden files. Most of the time, you might need to work with these files. You might not, but it's just a useful thing to know. The other thing as well is that you can see details on these files. So if we want to do ls-l, it will list the files, but also give details on it. So if you want to see, for instance, the documents that I have, you can see the timestamp it was last updated, meaning what time did I last create a file or update a file within documents. You can see the space that it takes up, which is very useful because then you can find out where all of your storage is going in case you're ever running out of space. You can see where it was made, which was staff. You can see the account it's associated with, in my case, admin. Honestly, I should probably change the name in the future. You can see its index, which is pretty much the order of which it was created relative to other ones. So for instance, this OneDrive one was created with index 1. And then you can also see permissions as well. Permissions we won't go over in this lecture, but at a very top level, a way of thinking of it is who can see it, who can edit it, and who can run it if it is a bash script. So bash script is not only something that you can type into the terminal, it's something that you can create programs with and then run them later on if you're willing to change the permissions that you can run them. Now, the thing is that I've only shown you ls-a and ls-l. There are so many other flags you can pass, and the way to find that out is with 2 dashes and typing in help. And this is universal to every command. So cd, mv, which stands for move, which you'll learn about in a bit. All of these can be passed ~help, and this will list the very options that can be used. Is it ls-help in my case? Yeah. Oh wait, not in this case. Maybe it's different because it's Mac. Should test it on this computer because it might matter. Yeah, it might just be a Git thing rather than a Mac thing. Yeah. So for Linux, technically, if you were to pass ~help, it would give options on how to do it. For Mac, it's something else, and I'm not too familiar with it because I've literally just started working on a Mac today. But I'm going to load up Yasin's computer in a bit, which is running Linux, and this should hopefully be able to show what this does later on. In the meantime, we'll carry on. So if we check where we are, we're in users admin. We'll switch to downloads, and we'll switch to tutorial. Dash help, 2 dashes, I think, unless it's different. Yeah. Yeah. So as you can see, these are the different flags you can pass through. So if you go to where dash A is, it should say, I believe, all in as part of the title. Yeah, there. So double dash A, double dash all, or single dash A. Either will work, and it will basically not ignore those files starting with dot. The files that do start with dot are those that are hidden. Similarly with dash L, it will list all the stuff, and usually all of these flags will say what it does. Now if you type in mv double dash help, these will give options related to a command which we'll learn about later, which is move. As you can see, there's more options that are specific to that. So for instance, there's no dash A because there's no all for it. There may be other things like dash F, which stands for force, or I, which stands for interactive. You'll learn more about this as you interact with it, about the different flags you can pass through and how they may be useful. But inshallah, we'll continue with the rest of this on my computer, and inshallah shouldn't need to run help for the rest of this tutorial. Otherwise, we might run into some issues. But, just checking if everyone, well, really, I can't even see myself. There. So, continuing here, we'll learn a few more commands. So the first two I'd like to talk about is touch and nano. Put simply, touch either creates a file or updates the timestamp. As I mentioned before, there's a timestamp that's associated with folders. You can update this to make it seem as if you last updated it just recently. Now, this might be useful in a server case where you maybe wanted to find the most recent file or the most recent user. You may just run this command because you want to quickly update the timestamp without needing to edit it. Think of this as like a Word document. It doesn't update by itself. You need to open it, maybe edit it a little bit, and then close it to actually get the timestamp to update. You can't just open and close it. The other one I want to talk about is nano, which allows you to not only create a file, but also edit it. So you'd be able to pretty much do all of the things that you need to with that. But first, let's create a file. So in this case, if we first type in ls, as you can see, there's no files. We're going to create a file called, be very unique and call it file1. What this does is if we ls, now we actually have a file called file1. Now, let's actually open up this file and work with it. The way that we do that is with nano. We'd open up file1, and now we are presented with a new sort of UI, a user interface which we work with. It's no longer the terminal we're working with, but something else entirely. This is, is that rising? This is Nano, a text editor. So pretty much think of this as a very watered down version of Word. Yes? The file type of? I should have specified this as a TXT file. But the way that it actually works is if in any text opener you open a file, it will try to automatically translate everything to TXT, I believe, unless you specify further. So like, for instance, with VS Code, any file you open, it'll try to treat it as a text file, and it might break unless you have an extension. You can inshallah learn this in the other tutorials, maybe the Python one, I think, but we'll find out. So in this case, it is technically an untyped file, but if I were to do .txt, in most file systems, it'd be considered a text file, unless you have your operating system decide otherwise. So from here, we now have file1, and we're going to add a new line. I'm just going to type in new line. So now we have a file called file1, which has the line new line. Now, the nice thing about Nano, and why I prefer it to another editor called Vim, is that at the very bottom, you can see the main commands that you need to worry about. Main one being how to exit. With Vim, once you get in, you need to search on Google how to actually get out most of the time. What's happened? Oh, so what type of file was created? What type of file was created a TXT? Does someone want to clarify what they mean by this? Yeah. Oh, yeah. Yeah, in this case, it was basically an untyped file, but the moment we open it with Nano, it treats it as a TXT file. but it's still technically untyped until we pass in the .txt. Next question is, I don't get why we would pass a flag. Main reason is that when you use some future commands that I'll teach in this tutorial, you'll see why flags are important. So for instance, when we're removing directories, it is impossible for you to delete the directory without passing in a flag to specify that we want to remove specifically a directory. Because then you start to encounter some dangerous operations where you can potentially remove your entire operating system without passing flags to say that, hey, I know what I'm doing and I want this specific functionality. So continuing from where we were, we created a file called newline. And as you can see in Nano, we can easily see that it's just Control and X to exit. Now, when we are planning to leave a file in Nano, it tells you, do you want to save the modified buffer? What this basically means is you've typed some stuff into this file, you've edited it somehow. Do you want to save it and continue? This is very useful in case you accidentally open a file. You may accidentally delete a letter or another letter or two letters or whatever, and then leave, and then suddenly this breaks everything and you're trying to find out what's going on. This way now tells you, hey, you've made a change. Are you sure you made a change? In this case, you do yes. And then you write the file name that you want to write this to. So what this means is we're now given the option, do we want to create a copy of the file that we just edited? So for example, imagine you make a CV, you edit it, you may want to save that as like CV2 or CV final or something else. This allows you to create a copy which now has that new line added to it. So in this case, we'll just create the .txt and just save it as a text file, as it was mentioned before. Now if we ls, we see there's two versions, file1 and file1.txt. This brings me on to the next command I want to teach you, which is cat, which basically means, yes?
Sorry, just quickly, when you were naming it just then,
Yeah.
can you specify any file type?
Pretty much yes. But the thing is that all you're really doing when you add that .txt is you're giving it an extension, which is pretty much just a glorified name. If I were to name it something like docx, which is, I believe, Word's extension, what would actually happen is you can still edit it like a text file in Nano, but now it means that file is openable by Word, and if it isn't in their specific format, it will just come up as a corrupted file. So in other words, if I save something as a .pdf and a PDF can't actually open it because it's just a text file, it will just crash or say it's corrupted. Hence why you tend to see that sometimes some files get corrupted because they were created and they're just given the wrong extension, or maybe some random character has changed somewhere that breaks its formatting. So, continuing from where we were given, we were going to go over cat, which pretty much what this means is list the contents in this file. So, you pass the file name that you want to print out. In this case, it's file1.txt. And it will say the line that was written to it in Nano, which was new line. We'll do the same with just file without the txt or the one. File1, I think it's called. And you'll see that nothing was output because file1 never had those changes. Now it's a good time to actually move to the next command, which is rm, which stands for remove. As mentioned before, I made a file1 that didn't have the txt ending, and now I actually don't want it anymore. So what we can do is rm file1 and ls, and as you can see, it's no more, it's been deleted. Now, from here, let's say we were to create a directory as well, and call this tutorial1. I'm having an issue there. Mukdir tut1, tutorial1. And now, I want to move this file, the file1, into tutorial1, because this is the first tutorial for Linux. Inshallah, there's many more, but we'll find out. And we want to move that file into here. This is where the move command comes in handy. So how this works is we pass in the file we want to move, which is file1.txt. And then we say, where do we want to move this to? And in this case, we'll move it to the folder we have just created, which is tut1. So now, if we run ls, we'll see that there's the folder, tut1, tutorial1. And if we go into the folder, and just pwd to show that we're actually in that folder, and run ls, we can see that file1 has been moved there. This is the power of the move command. It allows you to basically move things as if you were drag and dropping it in Finder. Now, suppose we wanted to have file1 back in the original folder and in the current folder. So if we wanted it to appear both in tut1 and tutorial, this is where the copy command comes in very useful. So what we can do is create a carbon copy of file1 and move that to tutorial rather than just tutorial1. So the way you do this is cp file, and then you say relative to where you are, where you want it to go. So in this case, I want to move the file to its parent. If we do that and run ls, you can see the file is still there, just proving that the contents are still the same. It still says the new line. Now we can go outside into the parent, which is tutorial, and then we can once again run file1.txt, cat it, and you can see that once again we've created a copy of file1.txt, both in the tutorial folder and in tut1. Now let's say that due to budget reasons, STEM has decided to shut down or whatever, and now we no longer have future tutorials. Now we don't need tut1. So we'll try to remove it. But now we're given an issue that tut1 is a directory. This is where flags comes in handy, as I mentioned earlier. So in order to actually remove this, we need to pass in the command, the help flag -r, which stands for recursive. What this means is it goes into the tut1 directory, goes in as far as it can in terms of directories, and delete all the files within that directory, leave out of that parent, and then delete the directory itself. By doing things this way, if there's thousands of files inside, we make sure each and every file gets deleted before deleting the directory itself, making sure that the disk space is freed. What this means is that it makes sure every single file is deleted, so that if you have like a 100 gigabyte folder, that you aren't just deleting the folder link and keeping those 100 gigabytes there and just taking up space for no reason. This is very important in Linux, otherwise you end up with a file system that's basically full even though you can't access any of these files. So rm-r will remove tut1. Oh yes, you also need to pass the f flag as well, which means to forcibly remove it. Now, if we ls, apparently not.
You see
Oh yes, rm-rf and also tut1. So you need to pass in the file that you actually want to delete as well. So doing that, if we print ls, we can see that tutorial1 is no more. But we still have the original file1.txt, and if we were to cat it, in other words, print out if we were to cat the file, we still see that the file exists even though we copied it from the child folder inside. So this shows that even if you create a copy and you delete the original, the copy still persists, which is very important because you don't want to delete something and then find out that a lot of files are now missing. So from here, what else is there to go over? I believe that is everything for this tutorial.